guys, this is Mrs. Gastler, and in this video we're going to talk about x versus t graphs with constant acceleration. In our previous unit we were only looking at constant velocity, and so now we're going to see what it looks like when the object is changing speed. So I have my lesson 5 notes page here. It might look a little bit different to you, it's okay. The first thing I want to do is I want to kind of compare constant velocity and constant acceleration so that we can kind of get a feel for it. And I'm going to make a sort of Venn diagram thing going on here. Okay. And we're going to start with what they have in common first, okay? So the first thing that they have in common is if it goes up, that means that it's going in the positive direction. That's the same as it was in the constant velocity. And if it goes down, whoops, down, I forgot the end. That means it's going in the negative direction. And that is the same in both constant velocity and constant acceleration. So remember, that's as we go to the right. It's like we're reading a book. So as we go on the graph, as we go to the right, if it goes up, it's going in the positive direction no matter what it looks like. And if it goes down, it's going in the negative direction no matter what it looks like. Okay. So in a constant velocity graphs, what we were seeing, though, was we always had straight lines. Okay, all of our lines were straight, even if they were flat. And flat meant that it was stopped. Okay, flat meant that it was stopped, but it was always a straight line. So maybe it was a straight line that went up, maybe it was a straight line that went down, maybe it was a flat line, but it was always a straight line. With constant acceleration, our lines are always going to be curved. Okay, we'll have curved lines. If we have flat, then we're really talking about constant velocity, but it might become flat. Oh, another thing that they have in common is that the slope of the line is still equal to the speed, but that's a little harder to see on the constant acceleration graph. We won't be measuring the slope on an x versus t graph in this unit because you don't have the math skills. It takes calculus to be able to do that. And so we just won't do that. So let's talk about all the different accelerated motions. So we could be moving in the positive direction. Okay. In fact, there's two things that we could be doing in the positive direction, so I'll put both of those in here. We could be speeding up, and we could be slowing down. Okay. And to review, we've got some motion diagrams here. So I'm going to draw a motion diagram to begin with. So here we go. So let's see, if we're going in the positive direction, that means I'm going to be going to the right. And if I'm speeding up, that means my dots are going to start out close together and they're going to get farther apart like that. My arrows are going to get longer like that. And when I add in my acceleration arrows, they're going to be pointing in the same direction because I'm adding a little bit to each of my arrows as we go, okay? If I were to measure this and plot this on a graph, we saw that in the Down the Ramp lab, it looks like this. And we've talked a little bit about your slopometer. Here's my slopometer for the day. I need a tiny one for these videos here. And we just put it on the graph and we kind of line it up as we go, and you'll see that the slope is getting steeper as we follow that line. So this one must be getting faster, okay? We're going to do the same sort of thing here on the next one, but we're going to be slowing down now. So now my dots are going to start far apart and they're going to get closer together. I have to tell you that it's harder to draw those. It's fine. Start with long arrows that get shorter. And because they're getting shorter, that means I have to subtract from my arrow. So my acceleration needs to be pointing in the opposite direction. So I'm going to draw my little acceleration arrows this way. Okay, so that's a nice review of the last lesson. On this graph, when I draw this one, I'm still starting at the bottom because I'm going in the positive direction, but this time I need it to get less steep. So it's going to start out really steep, and then it's going to get less steep and less steep and less steep. If it stops, it'll become flat, okay? So I can follow it with my slopometer here. I can go with the line and see how it's becoming less steep, but it's still going in the positive direction because it's going up, okay? Now the other two scenarios would be going in the negative direction. And we'll look at, whoops, forgot the word, in negative, whoops, I can't right now. Okay, direction, there we go. All right, and we'll look at speeding up and slowing down for these two, and then maybe we can talk about some similarities that they both have, okay? Excuse me. All right, so here's my motion diagram. This time I got to start on the right side because I've got to go this way to go in the negative direction. Speeding up means my dots are going to start out close together and they're going to get farther apart, like so. And my arrows are pointing to the left because I'm going in the negative direction. Look how similar these are. Interestingly enough, my acceleration arrows are also going to point in the negative direction because in the same direction gives us longer velocity arrows. So they're in the same direction. Look at that. Isn't that cool? The only difference is the direction that the arrows are going. So this one is slowing down and speeding up. Everything else is the same. It's pretty cool. All right, so on this one, I have to start up at the top and go down in order for it to be going in the negative direction. And I'm going to start out less steep, and I'm going to get more steep. So what that's going to look like is this, okay? So less steep. As we go along, I get more steep, so I'm going faster, okay? So these two are both speeding up. What do you notice? Oops, let's get them both in the picture here. What do you notice about both of these graphs that they're both doing? They're both starting out very low, like almost flat, and they're both getting really steep, so they're kind of going away. So that's something that they have in common, but this one is going up and this one is going down, so down, okay? All right, now last one here, let's take a look at going in the negative direction and slowing down. So we're gonna start out with really far dots that are gonna get a little closer together each time, like that. And long arrows that are gonna get a little shorter each time, like that. And now because it's slowing down, my acceleration arrows have to point in the opposite direction, and so they're gonna go like that, okay? So when I draw this graph, I'm gonna start at the top again, but this time I'm gonna start out steep. So this line is gonna come down quickly and then kind of level off, okay, like that. So if I follow it with my slope-o-meter, it's very steep. See how steep it is? And it's going down, so that's negative. And so when I follow my line, see how it's getting less steep as I go? Okay, I'm just following the line. I could put my fingers on the line and go like that if that helps, okay? But it starts out steep and it becomes less steep, so that one is getting slower. So take a look at these two that are slowing down. Notice how they both start out very steep and they both end up kind of flat. Okay, and that they're the opposite of these, right? Flat to steep, steep to flat, okay? Positives go up, negatives go down, and those are x versus t graphs with constant acceleration. Thanks for watching. Let your teacher know if you have questions.